My name is Shashank Sahu, and my final project for data mining is contraceptive method choice, which is guided by Professor Martin. So, first I have installed all the packages here in the top. Then, for data acquisition, I have acquired the data set from the UCI machine learning repository, which has 1472 instances with 10 columns. So the main objective of this project is to analyze the behavior of parents in Indonesia, so that it will be helpful to further understand the best method of contraception method used by the women, so that it can be helpful to improve the family planning program in Indonesia. So for that, I have followed the crisp DM process, like collecting the data, exploring and preparing the data, training a model on data, evaluating the model performance, and improving the model performance. So first, collecting the data, I have called this data from my desktop cmc.csv. So after calling this data, I get this data set. So there were no column names in my dataset, so I have added column names uh, in my dataset. So as you can see, wife age, wife education, husband education, number of children, wife religion, is wife working or not, husband education, standard of living, media exposure, and contraceptive method used. So there were no missing values in the original dataset, so I have removed the values randomly, and later I have performed imputation and fill the removed values. Here I have converted the variables into something that can be more used for the pre-processing. So for data exploration, I have explored the data set by plotting graphs, bar chart and pie chart. So uh, the first graph is for the column contraceptive method used. So it shows that 594 women do not use any contraceptive method, 331 used for the long time, and 511 women have used for the short time. So this is a pie chart of the method, and this is a plot between wife education and contraceptive method used, which shows that the uh, education level from low to high and from no use to short term. And this is the bar plot for contraceptive method used between the number of children and count. For example, the red shows that women have not used the method, green shows they have used for the long time, and the blue shows that they have used for the short term, and this shows the number of children the women have. So coming to outliers, so there were no outliers in my dataset. I have detected it by using the histogram. As you can see in the histogram, there were no outliers in the column wife age. Now, coming to correlation, I have used the method Pearson moment of correlation to find the collinearity analysis. So I have used this method between numerical features, that is wife age and number of children ever born. These two column are my numerical features. So the Pearson the correlation came out to be 0.54%, which is considered to be strong. Now here I have done data imputation. As you can see, there are NA values in my data set which I have removed randomly. So I have imputed these values by using the mean of the values, and from the summary you can see that there are no missing values in my data frame. Earlier there were missing values in my data frame. I will show you now. So yeah, here there are 12, 8, 10 missing values are in my data frame. So now there are no missing values in my data frame. And yeah, so coming to normalization, there is no need to normalize the dataset because there are no skewed dataset in my dataset. I have We have already checked that by plotting the histogram. So I have only used no, standardization based on different features. And now to select the required features, I have used the correlation matrix. So this is the correlation matrix of my required features. So I have the best selected feature is PCA because it will allow me to see the overall shape of my data so that I can identify which variable are similar to one another. So here you can see that the variable 1 and that is PC1 and PC2 are highly correlated with each other with their proportion and the cumulative variance. From here you can see, okay, yeah, from the graph here you can see. So I've used PCA here and plotted the graph. Now coming to model training, I have again pre-processed the data in my imputed dataset, and I have splitted my dataset into two parts: 75% for training data and 25% for testing data. Now the first model which I have used is decision tree. So I have plotted a tree here. This is my decision tree, you can see, and I have evaluated and improved the model performance. So after evaluating, you can see that the accuracy came out to be 54.7% with kappa value of 29.39%, 0.29. So I have found the accuracy by using the confusion matrix here. And the next model which I have used is neural network. So here the accuracy came out to be 53.8% and the kappa value is 0.2874. The final values are used here for the model whose size is 5 and decay 0.1. So I've also plotted a graph for the neural network here. This is my graph between weight, decay and accuracy. So after training the neural network with about 100 iterations, I found out that accuracy is still not better than any other method. So I have used another method, that is random forest. So I have trained the model here. Then I have evaluated the model performance by plotting the graph. Then I have explored the different trees in the dataset. So this is a error rate versus trees in my dataset. So the black curve represents the out of the bag error. This one, as you see, is the black curve. So and others are the misclassification error rates as stated in the dataset. The error rate is a prediction error rate, the black one. The error rate of error based out of bag error rate is higher than the prediction of the original dataset. So that means there is higher error rate in my dataset. After that, uh, I have also plotted a tree between this dataset. So as you can see, the most important predictor, the media exposure and the wife of religion of the woman are the important factors in our random forest algorithm because they are the very least. So as also the age of the wife is not as important. So now improving this model performance, I have found the accuracy by using the confusion matrix. So the accuracy came out to be 52.7%. Then I have again tuned this model by changing the value from 1 to 2 here. So the accuracy is changed to be 51.7%. So whenever I run this model, the accuracy is still changing, but it does not fall below 50% or go beyond 53%. And this is the uh, in prediction results which I have drawn here. Now the fourth model which I have used is SVM. So here I have used k-fold cross validation here. So the I have found out the accuracy by using k-fold cross validation, and the accuracy came out to be 54.08% with kappa value of 0.2809. And I've also used holdout sampling method in SVM, and in which the accuracy came out to be 53.26%, and the kappa statistic is 0.2681. So you can see here there is not much difference between the accuracy. So we can say that by using any method we get the accuracy almost similar. So this is the comparison of all my models. For decision trees, accuracy is 55%. For the neural network, accuracy is 53.6%. For random forest, accuracy is 52.4%. For k-fold method, accuracy is 54.08%. And by using holdout sampling in SVM, accuracy came out to be 53.26%. And you can also see the variations in the kappa value. So I have used bagging for improving the model performance. So after using this method, uh, you can see that there is decrease in accuracy. For wife, religion to number of children, there is increase in accuracy, and same for the decrease in kappa value. So you can see here the accuracy. So after using bagging, the neural network accuracy has been increased to 63%. For SVM it increased to 62%, and for decision trees it increased to 67%, and for random forest it can go max to 51%. So here we have tuned the model and increased the accuracy. And now coming to stacking the ensembler model, I have created this ensembler model in which I have included the neural network, decision trees, SVM, and the random forest, the models which I've used in my project. So you can see here the graph between accuracy and kappa. So also you can predict from here that accuracy has been increased slightly for every model. So and the kappa values have also increased slightly. Okay, so yeah, now I've also created a rshiny dashboard to upload my CSV file. I will just run it. Yeah. So I'll browse it from my system, and this is my CSV file. I will open it, and yeah, you can see. Okay, I will display you the overall result. Yeah, so you can see that these are my data sets. You can compare here. Age, you can see the columns here. So I can also use semicolon to separate, or comma, or I can remove the headers, as there are no headers in my original data set. So that's why it is showing by default x24, x2, x3. So this is my rshiny dashboard. So I have followed the crisp dream process: collecting the data, exploring and preparing the data, training the model on data, evaluating the model performance, and improving the model performance. So I have used 4 models for which I have got the accuracy almost similar to each other. There are not much difference between the accuracy and also in the kappa values. And conclusion is very few models provided any sort of reliable results. You can see the accuracy is similar or slightly closer with each other. So having a neural network trained over 100 iterations did not make any significant changes in accuracy, because the accuracy is very similar to the random forest and SVM. And also I can conclude that having accuracy greater than 33% means that the models were trained well. This ongoing practice will help me planning the family